Welcome back. In this video, we're going to talk about the other two trigonometric ratios, sine and cosine. And the reason why you need three trigonometric ratios is that no matter what information you're given in your triangle, you are always able to solve for an unknown side. So the sine is defined to be the ratio of the opposite side over the hypotenuse, and the cosine is defined to be the ratio of the adjacent side over that hypotenuse. So as you can see, one of the trickiest thing is to remember what's sine, what's cosine, what's tangent. And so there's a very familiar mnemonic that a lot of people use, and it is so, K, toa. So, K, toa. And you'll hear people say, so, K, toa. That helps you remember that the sine is the opposite over hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. And maybe your parents even remember so, K, toa. All right, let's look at example 1 in this section 9.8 if you're following along in your book. And we want to find the sine of L, the cosine of L, the sine of J, and the cosine of J. So the sine, so, opposite over hypotenuse. We want the opposite over the hypotenuse. I'm going to write that down there. Go to L, go to the vertex of L, and find the opposite side. Remember, the hypotenuse is always the hypotenuse. I'm going to label this with an H, and you might want to label it with an H. The hypotenuse is always the hypotenuse. These two sides will be the opposite and the adjacent depending on what your perspective is. So here we're at the perspective of L, sine, so, opposite over hypotenuse. What is the opposite side? Is it 8 or 15? I hope you all said 8. And then the hypotenuse is 17. So the sine of L is 8 over 17. Now let's find the cosine of L. So K is A adjacent over hypotenuse. From the perspective of L, adjacent side would be 15. The adjacent side is always part of the angle. Each angle consists of the hypotenuse and then the adjacent side. So from L, adjacent is 15, and the hypotenuse is always the hypotenuse, no matter where you are. Now let's go to angle J, and we want to find the sine of J. So you say in your mind, sine, so, opposite over hypotenuse. Here you are at J. Opposite would be, did you get that? 15 over 17? And then the cosine of J, cos, K, C-A-H. Adjacent over hypotenuse. What's adjacent? That would be 8 over 17. And there you go. I'd like to point out that in this right triangle, J and L are called complementary angles because they add up to 90. And notice that the sine of L is the same as the cosine of J. Cosine. cosine, complementary to the sine. They are equal, and these also are equal. That's just a little note. All right, how do we use this? Well, let's look at example 3. We have a right triangle. We have an angle. We know the hypotenuse is 16, and we want to find what side. What side is this in respect to 41? Is it opposite or adjacent? I hope you all think it's the adjacent. So then we say, okay, we don't know the adjacent. We want to find the adjacent. We have the hypotenuse. Which trig ratio works with adjacent and hypotenuse? That would be cosine. So we will write our trigonometric equation, the cos of 41, so k, adjacent over hypotenuse. Adjacent is our unknown. The hypotenuse is 16. And just like you solved your tangent functions, we will do this. Grab your calculadora, and we want to find the cosine of 41. So here's cosine of 41. Enter, we have the long decimal. And what will we do to both sides of this equation, class, to solve for x? I hope you said multiply by 16. So leaving this on the calculator, remember, now multiply by 16. And we get 12.07. If we were to round that to one decimal place, that would be 12.1. So x is equal to 12.1. Either we don't have any units or I forgot to put them in, so we'll just leave it at 12.1. Here's another example. Example 4, our right triangle. Here's our angle. And we know the hypotenuse. The hypotenuse is always across from the 90. This is the hypotenuse. And what side do we want to find? Is it the adjacent or the opposite to 27? It's the opposite, right? So then you have to ask yourself, which trigonometric ratio includes the opposite and the hypotenuse? That would be sine. So our trigonometric equation will be the sine of 27 is equal to the opposite, which we don't know, over the hypotenuse, which is 164. And once you get to here, this becomes pretty clear-cut, hopefully. We find the sine of 27, sine 27. And then to solve this for x, we need to multiply both sides by 164. So multiply by 164, and we get 74 that would round off to a 5. So x, I should be putting approximately equal to 74.5. All of these are approximations using the trigonometry. Oh, and we have a feet, so we should label that feet. Okay, one last problem. This is number 4 on page 522, if you'd like to go there. And I decided not to set it up so I could walk through the setup with you. A radio tower, a support wire 225 feet long, is fastened to the top of a radio tower. The wire makes an angle of 70 degrees with the ground. How tall is the tower to the highest foot? So in these types of problems, and you'll get these kind of problems right through calculus, it always is a building, a tree, a mountain. Now we have a radio tower. We're assuming that this is perpendicular to the ground. That's how we have our right triangle. And we're told that there's a wire that goes to the top of the tower, and that wire is 225 feet long. And we're also told that the wire makes an angle with the ground of 70 degrees. And then we're asked, how tall is the tower? So how tall is the tower would be this dimension. They could have asked us how far away from the base of the tower is the wire tied down. We could find that, right? All right, but this is what we have. Now you have to label the sides of your triangle. Well, the hypotenuse is always across from the right angle. And then from the perspective of the 70, what is this side? This side would be the opposite. Great. And once you know that, then you can determine which trigonometric ratio, sine, cosine, or tangent, involves the opposite and the hypotenuse. That would be sine. So we must say that the sine of 70 is equal to x over 225. Find the sine of 70. Multiply that by 225. And we get the height of the tower. They wanted it to the nearest foot. We would round that to 211 feet. 211 feet tall. All right, here's your homework. I don't want to confuse anyone, but knowing that you are bright minds, some of you might be saying, could I use the 30 degrees? Do you see, I'm sorry, 20 degrees? Do you see how this angle is 20? And the beauty of trigonometry is that there's an awful lot of different ways you could go about solving something. You could say, you know what, I want to use 20. Then this would be the adjacent. But you know that the cosine of 20 is the same as the sine of 70. So if you were wondering, that is another valid way that you could solve this problem. If you have any questions, please just let me know. I would be happy to do any of the homework problems in a quick little YouTube video. All right, take care. This is the last assignment before Easter. I hope you have a blessed Easter. I will see you next week. Bye-bye.